In this exercise, we'll get some basic practice of the pandas series and DataFrame objects. First, we're going to import pandas, and we're going to give it an alias PD. Next, I'm going to create a series starting from this dictionary. That's the same dictionary we've used before. It's basically the population of multiple states in the US. Next, I'm creating my series object by passing the dictionary, and I get a series in which the index is the keys of the dictionary and the values are the values. Let's take a look at these questions here. How many entries we have in population, the series? What are the values? What is the index of the series? What is the population of Florida? And next we want to extract a subseries of the population of Texas, New York, and Florida. So to answer the first question, there are many ways to get to the answer. One easy way is to basically use the length function. Length function in Python works for any sequence. And the series is basically a sequence of values. So we can do length population, and that will tell me that we have 5 entries in this series. There are multiple ways of getting to the same answer. We can actually access an attribute in the series called population size, and that will give me size. Or I can use a function called count. Now all of these are giving me the same answer. This is something we will see very often in the future. There are multiple ways to get to the same functionality in pandas and in Python in general. This is both a feature, a blessing, and also a curse at the same time, because many often we have multiple options, and knowing these options and having some practice with them help kind of getting to the same results in a more effective way. In the beginning, they may be daunting a bit because there are many ways of getting the same function, the same operation. Next, we are being asked to report the values. Now, don't forget that the series itself contains two things, the index and the values. If I want the values, I can use the attribute values, and this will give me a NumPy array of the values. Okay. If I want to convert this to a list, I can convert it to a list by passing it to the list function in Python. The other way to get to the values is basically to list the series itself, and this will immediately convert the series to a list. Another way to get to the values is to call the function toList from the series, and this will give me the values as a list. Again, multiple ways to getting to the same result, but basically this is extracting the values from the series. Next, we're being asked to report the index of the series. So we can get the index by accessing the index attribute in the series, and that's telling me that the index is an index object of California, Texas, New York, Florida, and Illinois. If we are being asked to report this as a list, we can convert it to a list. And converting it to a list, it's no longer an index object, just a list of the values of the index. What's the population of Florida? If you take a look at this series, we can eyeball the population of Florida. Basically, we want to implement this eyeball operation, which is called indexing. Knowing the index, which is Florida, give me the value. And this is done using the square bracket operation. The square bracket operator here will give me the value associated with the index. Last, we want to extract a subseries of the Texas, New York, and Florida, which is basically those following entries in the series. Now, very much like when we use the square bracket notation to get 1, again, let's copy this Texas to Florida. To get 1, we can use the same notation to get many, and we're going to use slicing in this case. Again, as we said in the previous lecture, a series is kind of a mix in between a list and a dictionary, so I can slice it like a list, but the slice can be using the index, the keys, very much like a dictionary. And what I get another series, and this series contains a subseries from Texas to Florida, the index, and also the values. Next, we are creating another series called area. That's basically the area of these states. We have a couple of questions. First, we want to create a data frame of the two columns, population and area. We're being asked to report the index of the data frame and also report the columns of the data frame. And at the end, how many entries are there in the data frame. First, I'm going to create the data frame. So I'm going to use the data frame constructor. And there are multiple ways to create a data frame. One way to create a data frame is to provide a dictionary mapping the column names, for instance population, to the sequence of the values in the column, which is basically the series population. And I'm going to map a column called area to the area series. Let's take a look here. And you can see here that we have a data frame, a table that has two columns, population and area. And those are basically the values from the series. Now, what's the index of the data frame? Very much like the series, we can use the attribute index, and that will give me the index. But this is the index itself is the row index. Here we're being asked to report the columns of the data frame, which is the other index. So to report the columns, we can do the columns index. So in terms of terminology, Pandas data frame uses the index to refer to the row index and columns to refer to the column index. And those two indices are called axes. So the data frame is a two-dimensional data structure. It has two axes, rows and columns. So when we say index, it's usually the row index, unless if I specifically say the column index, I'm basically referring to the columns. The last question is asking us to report how many entries we have in the data frame. So we've got 2 columns and 5 rows, which means we have 10 values in the data frame. So if we're being asked to report how many rows, we can do the length of the row index, which will be 5. If we're being asked to report how many columns, we can do the length of the columns, which is 2. And obviously, if I want to report how many values are there, that's basically, a multiplication of the length of the row index with the length of the column index. So that's one way to get to this answer. Now, the data frame itself has an attribute called shape, and shape basically gives you back a tuple, which is basically the number of rows and the number of columns. So another way to get to the answer is to get the shape. So we can get rows, columns is equal to df.shape, and then rows multiplied by column will give me the same answer. Once again, there are multiple ways to get to the same answer. Finally, in closing, I just want to say that by default, the length function, if applied on a data frame, is going to give me the number of rows in the data frame. So that's the default. If I want to get the number of columns, I need to say length df.columns.